Okay, folks, so let's continue with circles and concepts related to circles. Today, we'll spend some time learning about arcs, chords, and their properties. Okay, so let's assume we have two congruent arcs, right? What do we mean by congruent? If you've studied when you looked at congruency of triangles, that if any two shapes in general overlap, right, then they're said to be congruent. When it comes to triangles, you have certain conditions to determine if two given triangles are congruent, right? It could be if all three corresponding sides are equal, if two sides and the included angle are equal, so on and so forth, right? You remember all the criteria for congruency. Okay. Now, when it comes to circles, right, you say two circles are congruent, right? When will two circles overlap? They will overlap if their radii is the same. If the radius of one circle is 5 centimeter and you have another circle with the same radius, then you say these two circles are congruent. Similarly, you will say that two arcs are congruent either, in the same circle, right? It's possible, right, that in a given circle, you can have two arcs that are located at two different places, but they can still have the same length. Or you can have congruent arcs across two circles, and these two circles in turn are congruent, right? Either which way, what we want to observe today is, look, if we do have congruent arcs, then, and they overlap, then you can make out that, let's say these are the centers of two different circles and the radius is the same of both of these, okay? Right? Now, if the arcs AB and the arc CD, okay, are congruent, right? For example, let's say what we've actually done here, just hang in there, guys, for a minute. Okay, guys, sorry for the interruption. So let's say we were talking about the arcs AB and arc CD being congruent, right? Which means they overlap. So let's say I picked up the arc AB here, okay? I have the center O, these are the points A and B. I rotated it, right? And if I rotated it and I superimposed the same arc AB onto this circle, you'll see that they will overlap, right? Now, if it does overlap, then bear in mind that this central angle, we studied yesterday or in the previous video, that the arc subtended by, the angle subtended by an arc at the center is called the central angle of the arc, right? So if they do overlap, then obviously the central angles are equal. So whenever we talk about equal arcs or congruent arcs, right? So you show the arc like this, you talk about congruent arcs, then you can very fairly assume that the measure or the length of arc AB is equal to the measure or length of arc CD. Not only that, you can say that the central angle AOB will be congruent to or equal to the central angle CBD. Okay, guys, so this is something we will use in other theorems going forward. Okay, cool. So now let's talk about chords and arcs. Just give me a minute. Okay. So when we talk about chords and arcs, let's say there are two arcs of a circle, okay, or two different circles, but they are congruent. Either case, if these two arcs are congruent, then let's see what happens to their respective chords, right? So let's say this is center O, center P. I'll call this arc AB, I'll call this arc CD, minor arc of course, right? Now we are interested to know what happens to the chord AB and the chord CD. Okay, so let's join them. Now let's find out what is the relationship between the chord AB, sorry, and chord CD. Okay, right. So we already know that OA and OB are the radius of the same circle. And we also know that these two circles are in turn congruent, right? Which means the radius or the radii is the same. So we can very comfortably mark PC and PD to be equal to OA and OB. Okay. Now it's already given that arc AB, okay, is equal to arc CD. That's given, right, guys? So if this is given, what can you arrive from this fact? We discussed in the previous slide that whenever you say two arcs overlap or that they are congruent, of course, the measure of these arcs are equal, right? M is a measure, and the angle AOB is equal to angle CBD. Cool. So now if we were to look at triangles AOB and triangle BCD, okay, what can you make of these two triangles? Okay, if you can pause the video and ask yourself, can you tell me how these two triangles are congruent? Okay, so out here, you can say AO is equal to BC, OB is equal to PD, right? And angle AOB is equal to, sorry, I've not been writing the equal to sign, is equal to angle CPD, right? So by the SAS postulate, these two triangles are going to be congruent. Right, guys? So let's write this down by SAS postulate, triangle AOB is congruent to triangle BCD. If that's the case, what can you say about the remaining sides, right? From congruency of triangles, we've learned that if two triangles are congruent, right, these two triangles are congruent, then the corresponding paths are congruent, right? The corresponding parts of the congruent triangles are congruent. Or in other words, if you are, familiar with the acronym CPCTC, have you all used this? Yeah, if you're from the CBSE curriculum, you'll be very familiar with this. This means corresponding parts of congruent triangles are congruent. So instead of writing these words, you can just write by CPCTC. Okay, what is the corresponding part that's left here? Obviously, it is the chord AB. Hang in there, sorry. It is the chord AB. This is the side that corresponds to AB is CD, which means, guys, when you overlap, if I could cut this triangle from the circle and overlap it on CPD, then the part that falls beautifully on top of CD is AB. Therefore, by CPCTC, AB is equal to CD. Right, guys? So if you can just pause the video, make a note of this, right? And this is one of the outcome of two arcs that are equal in the same circle, or two arcs that are congruent across congruent circles, and the conclusion is that their chords are also congruent. Okay, so if two arcs of a circle or congruent circles are congruent, let me complete the sentence on top here for you. Then the corresponding chords are also congruent, are equal. What do I mean by corresponding chords? If these are the end points of the arc, then we're talking about the chord that is formed by joining the end points of the arc. Okay, cool. So this is, one of the theorems. Cool. Shall we proceed? Okay. The next one. Now we're going to talk about chords that are equal in a circle, or chords that are equal across two congruent circles. If we know that the chords are equal, then what can we say about the arcs? Okay, so it is the same diagram. Let's say center is O, center is P. Okay, this time the difference is that we are starting with the fact that, we know that the chord AB is equal to chord CD. Okay, guys, another important thing, when you are learning geometry, when facts are mentioned about shapes in words like this, okay, when you have some geometrical facts mentioned in words, always depict them in the diagram. You know why? As they say, a picture speaks 1,000 words. When you draw all this, just by looking at these two circles, you can make out one, that, oh, we are talking about two congruent circles, which means the radii of these two, the radius of these two circles are equal. You mark that. And we're talking about the fact that the chords are equal. So the minute you mark everything, right, this picture is actually speaking to you, right? The minute I've marked this, you know that triangle AOB is congruent to triangle PCD. Why is that? You see that, all the corresponding sides are equal. So please make this a habit, make this a best practice. Okay, cool. So from here, we can say that triangle AOB is congruent to triangle PCD. It's a straightforward conclusion, correct? Now, what do we mean? What can we deduce from this? From this, as usual, by CPCTC, right? By the fact that corresponding parts of congruent triangles are congruent, okay, we can say that angle AOP is equal to angle CPD. Am I right, guys? We are saying these two angles are equal. Okay, now when we started the class today, the video today, we discussed the fact that if the central angles are equal of two arcs, because here we have two endpoints, A and B, and on the other hand, we have the other endpoints of the arc C and D. So if the central angles are equal, then the arcs in turn are equal, correct? So I'll write it down again here. If the central angles are of, that's important to say, of what? Central angles of two arcs are equal, then the arc themselves, right? The arcs themselves are equal. Right, guys? Therefore, you can conclude that the measure of arc AB is equal to the measure of arc CD. When I say measure, we basically mean the length. Because look, when you're writing AB is equal to CD, so far in geometry, you know that AB represents a line segment, right? Now, if I need a way to differentiate how we depict a line segment like this versus an arc, like this, then we just need a different mechanism, which is what we are doing. We write the endpoints and we draw an arc, a cap above it. Okay, so arc KB is equal to arc CD. So just to conclude, if two chords of a circle or congruent circles are congruent, then the arcs that they contain, when I say they, I mean the arcs that the chords contain are equal. Easy, guys? Okay, so please pause the video, okay, draw the diagram and prove this for yourself. Okay, cool.